particular medium due to the simultaneous vibration of two sound sources of frequency. There are two sound sources, maybe a tuning fork or something like that. The frequency of the first source is given like 212 hertz. Like that, frequency of the second source is also given 210 hertz, right? And the resultant wave is created due to the superposition of the individual waves. Which of the following best represent the variation of the displacement x of a particle in the medium versus time? Displacement and time graph, right, from this. Now, if you sound two sources of nearly equal frequencies, then there will be some beat frequency will occur. Let's say the beat frequency delta FB is equal to, right, the difference of the frequencies, right, 212 minus 210, that will be 2 hertz. So, right, this will be 2 hertz. Beat frequency will be 2 hertz, right. That means, right, you know a formula, time is equal to 1 over f, right, period of oscillation is 1 over f, right. From this, if you find delta t is equal to 1 over this 2, that means 0.5 second, right. That means beat in the sense every 0.5 second there will be some maxima in the displacement, right. There will be a maxima, then thereafter some minima, maxima and minima, like that the graph pattern should be. Look at this carefully. Each 0.5 second there will be a maximum amplitude, then 0, maximum after 0.5 second maximum, after 0.5 second maximum. So this will be the possible option, the fourth one, right. As we know, right, if we want to heat a liquid, we have to keep the liquid inside a vessel, right, inside a vessel. So when we heat, what will happen? The vessel, the volume of the vessel will also expand. Because of that, the liquid level will go down by a level, say x. Initially that was in a level x, and now the level is go down by x. If the expansion of liquid is higher than the expansion of the vessel, then the level will rise up to a level z. So a person who is observing from the outside, right, let's say a person is observing from the outside, right, he will think that the liquid is expand from x to z. It's not so actually, right. Due to the expansion of the vessel, the level is go down from x to y, and then it is expanding from y to z. So y to z is the real expansion. Y to z is the real expansion. Real expansion, right. Xz is the expansion observed by the observer, that is the apparent expansion, right. Due to the expansion of the vessel, the liquid level went down from x to y, no. So the xy is expansion of vessel, expansion of vessel, right, expansion of vessel, right. So from this there is a formula called gamma is equal to a plus g, where gamma is the real expansion of the liquid. Volume expansion, expansion in the sense volume expansion. Real, we can say gamma as the right right, real volume expansion, expansivity, real we can say real volume expansivity of liquid, right. A is apparent volume expansivity of liquid, but G is volume expansivity of vessel, right? So this formula we have to know. Now we can come to the question. Question is there is a copper vessel, copper, and a silver vessel. They are using a liquid, right? The apparent volume expansivity of a particular liquid relative to copper and silver are, right, gamma C and gamma S, right? That means we can apply this formula. Gamma is equal to A plus G, right? Gamma is equal to A plus C. So if we apply this for copper, right, the real volume expansivity of the liquid is equal to gamma C plus 3 alpha C. Alpha C is actually the linear expansivity of the copper, right? If you multiply that by 3, that will be the volume expansion of the vessel, that means the copper. This is the apparent expansion of the liquid, right? Similarly, we can apply this for silver, right? If you apply the gamma, that means the volume expansivity of the liquid is constant. So that is gamma, that will be the apparent expansivity in silver plus, right, 3 times the linear expansivity of the, right, silver. That means linear expansivity of the vessel, silver vessel, right? So if you equate these two, then gamma C is plus 3 alpha C is equal to gamma S plus 3 alpha S. From this, if we find alpha S, linear expansivity of silver is gamma C minus gamma S minus plus 3 alpha C over 3. The option is the first one. A compound microscope is constructed by using 2 convex lenses of focal length 6 cm and 2 cm. Microscope. So microscope, there are 2 compound microscope in the sense there are 2 lenses. One is the objective, other one is the eyepiece, right? So let's draw a simple diagram to illustrate this. Compound microscope is there, right? This is the objective, this is the, is that correct? Yes. Eyepiece, right? In microscope, the focal length of the objective is less than the focal length of the eyepiece. That everyone aware about that, right? This is the compound microscope, right? This is the principal axis. An object is placed here. We don't need to draw the full ray diagram, but rather we can simply draw an object. An object is here placed near the objective lens, and for our easiness we can draw a ray passing through the optical center of the lens, and that will form an image, right? And that image will be the object of the eyepiece, right? This will be the object of the eyepiece, and the final image is formed, right? Final image is formed somewhere here, right? It is a magnified image and inverted image. Let's say this height as capital H, and this is H, and this is HO, and this is H, right? I will be the object for this eyepiece, and This will be, this I dash will be the image for this eyepiece, right? The focal lengths are given. This is actually smaller one, right? 2 centimeter, and other one is the 6 centimeter. This is 2 centimeter. This is 6 centimeter. Right, the sign convention that we are using nowadays is right. If you measure any distance along the direction of the incident ray, then that will be negative and the other directions are positive. Right. So what we can use is we can use the lens formula, or if you can remember the formula, you can directly use that one. Right. Okay. The focal lengths are given. Right. 6 and 2. A person whose least distance of distinct vision is 30 centimeter. That means this D, this is D. The final image is formed at D, 30 centimeter from the eyepiece, because the person will place the eye near the eyepiece. So this will be the D, right? Then the question is what is the linear magnification of eyepiece? According to the theory, the linear magnification of the eyepiece with respect to this distance of clear vision D and the focal length of the eyepiece, that will be D over Fe plus 1 according to the theory. D is 30. Focal length of this eyepiece is 6 plus 1. So this is 5 plus 1, the answer is 6. Otherwise, you have to derive, by using the lens formula, you have to derive the equation, right? So this is the most easiest way to find the answer. The option is the fourth one. Fourth one is the correct option. Right. Question number 14 is, right, there's a current carrying loop, right? A current carrying loop. The given figure shows the wire loop constructed using two concentric semicircular and a quarter circular segments. Right. This is semicircular and this is quarter. Right. Two segments. Right. And we have learned, right, if there is a circular shape loop, right. Right, this is the theory. Carrying a current, say I, and O is the center and R is the radius. Then the magnetic flux at the flux density at the center B is equal to mu naught I over 2R. This is the theory. So this theory we have to know, right? And the direction we can use right hand grip rule we can use, right? So if you take the right hand and except the thumb, other fingers you have to point out the direction of the current, then thumb will be outside the paper. So in this case, right, outside the paper in the sense it will directed towards you, dot. Now we can come to this question, right? There's a semicircle, so the radius is 2R for the semicircular loop. So for the 2R, if the magnetic flux originated at the center is B1, we will find the magnitude first. This is semicircle, so if it is a full circle, then mu naught I over 2 into R. R is the radius of the circle. Here the radius is 2R. So 2 is the value appearing in the formula. R is the radius. R is 2R. 2R in the sense, right? It will be like this. Okay. But it is a semicircle, so we have to put half here. We have to put half here. Right. Right. So the value will be mu naught I over 8R. The direction is same, dot. Right. For the quarter circular loop, we can also use the formula. Let's say the magnetic field strength at the center O, that will be mu naught I over radius is R. 2 R is okay. If it is a full circle, then mu naught I over 2R. But it is a quarter one, so 1/4. So this will be mu naught I over 8R, but the direction of the current is opposite. So this will be cross. So the resultant magnetic flux density or magnetic field strength, magnetic flux density and magnetic field strength are same, right? The terminologies are same. So at the center O will be, right, the summation of this. This is one is outward, the other one is inward, then B1 minus B2. So that will be 0. 0 is the possible option. Then that will be the fifth one. Right. If a converging lens of focal length f creates a virtual image of linear magnification m for a real object, what is the object distance? Let's draw a diagram for this. Okay. This is a convex lens. Right. This is a lens. Right. An object is placed right. An object is placed here, right, and a virtual image is formed. Right. If you want to have a virtual image in a convex lens, then you have to place the object right within the focal. This is the object, and this is the image. Right. The magnification is given like m. So as usual, we can indicate the incident ray, right? If you measure any distance along the direction of the incident ray, that is negative, otherwise positive. Right? This is the focal length, and the magnification is given. This is the mesh distance, and this is object distance. So the formula, lens formula, 1 over V minus 1 over U is equal to 1 over F, we can apply. By using the sign convention, V is positive, U is also positive, but the focal length is negative. Right? The question is object distance. So if you multiply this by U, U over V minus 1 is equal to minus U over F. This is 1 over M minus 1 is equal to minus U over F. Right? Now, if you multiply this by minus 1, minus 1 over M plus 1 is equal to U over F. U is 1 minus 1 over M times F. So the option is the first one.